Hi, 8th graders. This is the second part to 7.5's lesson. It's all of the exercises. So what you need today is a plain sheet of paper, like lined paper, nothing fancy. And at the top of your paper, I want you to write 7.5 exercises and your name. We're going to just try to go through and just see how far we can get before this video gets too long. I'm hoping that we can kind of get through most of these. Today we are working on proving if things are right triangles and using the distance formula to find the distance between 2 points. So let's go and get started with number 1. A quick reminder, if I write it down, you should also write it down for points. I don't just want answers, I want to see work as well. Okay, number 1. Describe 2 ways to find the distance between 2 points in a coordinate plane. All right, so it's saying, like, if I had, here, let me see if I can find a coordinate plane as fast as I can. Okay, here's a coordinate plane. If I wanted you, there's my y-axis, my x-axis. If I wanted you to find the distance between that point and, say, like that point right there, what are 2 ways you could do to find the distance between those points? Well, one way is you could, if you were given a coordinate plane, is you could create a right triangle. And I know it's a right triangle because it's like, landing in the coordinates perfectly. Then I could find out what the legs are. This leg is 2. This leg is 1, 2, 3, 4, 5. And then I could find what c squared was by using a squared plus b squared equals c squared, the Pythagorean Theorem. Okay, that's one way. Maybe so in words you could say, you could find the distance by creating a right triangle and using the Pythagorean Theorem. That's one part of the answers. And it says, I need a second way. Another way to find the distance between 2 points is to use the distance formula. Let's see if I can remember it from our song a couple days ago. It's the square root of the change in x's. So I don't care if it's x2 or x1. I don't care. It's just the change in x's squared plus the change in y's. Oops, that's a plus sign. Minus. Change means difference. Difference means subtract. Okay, and all of that will equal the distance. So I would write that for number 1. The 2 ways to find the distance between 2 points in a coordinate plane is to first, maybe you could create a right triangle and use the Pythagorean theorem to find the hypotenuse. Or you could use the distance formula, which is pretty much just doing that without, doing all the extra work. Number 2. Which one does not belong? Which set of numbers does not belong with the other 3? Explain your reasoning. So one of these cards is going to be kind of like a weirdo outlier. Well, let's look. The first one is 3, 6, 8. And then I have 6, 8, 10. 5, 12, 13. 7, 24, 25. Well, I don't have my answer key. I don't have my book. So if I was doing this problem on my own, kind of like I actually am right now, my first thought is, okay, what is the lesson about? The lesson is about distance, ordered pairs. It's also about right triangles and proving if something's a right triangle, right? So maybe the only thing that comes to my mind is maybe it wants to know if the 2 smaller numbers were legs, could that be the hypotenuse? To solve and find out, we can just use the Pythagorean theorem and check it. 3 squared plus 6 squared, does it equal 8 squared? Let's find out. I got my calculator ready to go. 3 squared is 9. 6 squared is 36. 8 squared is, 64. Okay, so 9 and 36 equals 45. Does not equal 64. Okay, so could 3, 6, and 8 be the side lengths of a right triangle? No, they couldn't. Before I, officially say maybe that's not what they're doing here, let's actually just, finish trying. Let's just check the rest. 6, 8, and 10. So the 2 smaller sides would be legs. 6 squared plus 8 squared equals 10 squared. Let's find out. 6 times 6 is 36. 8 times 8 is 64. 36 plus 64 is 100. 10 squared is 100. So these numbers do make a right triangle. Let's check the next set of numbers. So my two smaller sides would be my legs. I've got 5 squared plus 12 squared equals 13 squared. 5 squared is 25. 12 squared is 144. 13 squared, that's one of those ones I just don't have memorized, 169. Okay, so 144 plus 25 is 169. Okay, so yeah, this also makes a right triangle. I can kind of see what's going on here. I'm guessing that this last one is going to make a right triangle just because it would be the only odd one out that wouldn't create it. 7 squared plus 24 squared should equal 25 squared. Let's find out. 7 squared is 49. 24 squared is 576. Woofda. 25 squared, 625. Okay, so let's take 49 plus 576, and guess what? It equals 625. Okay, so yes, these sets of numbers also create a right triangle. So what is the set of numbers that does not belong with the other three? And explain our reasoning. In my answer, I would say 3, 6, 8. This set right here, because those three numbers could not be the side lengths of a right triangle. All the rest of these could be side lengths of a right triangle. Okay, number 3 and 4, it says, write the converse of the true statement. Determine whether the converse is true or false. If it is true, justify your reasoning. If it's false, give a counterexample. All right, so this is kind of interesting. If A, remember A is a side length. If A is an odd number, then A squared would also be odd. Well, let's just think about that for a second. What is some odd numbers? Got 1, 3, 5, 7, 9, 11, so on, whatever, right? 1 squared equals 1. 3 squared is 9. 5 squared is 25. 7 squared is 49. 9 squared is 81. 11 squared, 121. Okay, so what I'm noticing is that's odd, that's odd, that's odd, that's odd, that's odd, that's odd. And once, if the next number is 13, obviously if it ends in a 3, it's going to be odd as well. So if a number is an odd number, then the square root of that will also be odd. I'm saying that this is true. And how could you justify your reasoning? You could literally just list this right here. Doesn't that kind of justify it? 1, 3, 5, 7, 9, 11. They all create odd numbers. All right, number 4. If ABCD is a square. Okay, so let me draw a square. Oh, jeez. Goodness gracious. ABCD is a square. Then ABCD is also a parallelogram. Well, yeah, guys, if you can remember this, I'm trying to figure out why this has anything to do with the lesson we're doing right now, which is kind of silly. If ABCD is a square, then it's also a parallelogram. Well, parallelograms, the only attribute that something has to have to be a parallelogram is it needs to have 2 sets of parallel sides. So does this have 2 sets of parallel sides? Yes, it does. So if ABC is a square, then ABCD is also a parallelogram? Yes, it is. And your reasoning is because a square has 2 pairs of parallel sides. And that's all a parallelogram needs to have. I guess it also needs 4 sides, and it does have that as well. I don't understand, like, write the converse of the true statement. Determine whether the converse is true or false. If it's true, justifies your reading. If it's false, give a counterexample. Converse. Did we, like, learn something about converses in here? It doesn't look like it. I don't understand, like, why they would throw that in there randomly during this chapter, but... Oh, here we go. Something we didn't read. Write the converse of the true statement. Determine whether the converse is true or false. If it's true, justify your reasoning. If it's false, give a counterexample. Okay, so here we go. This is kind of important. I didn't know this was here. The converse of a statement switches the hypothesis and the conclusion. So, for example, if I said, here's a statement, if P, then Q. A converse of the statement would say, if Q, then P. So basically it's saying, can you reverse it and make it still true? That's going to change how we think about those two questions. Let me go back and check those out. Okay, so 3 says, if A is odd, then that means A squared is odd as well. That's a true statement. So it's saying, can we do the converse and see if it's also true? Let's reverse it. If A squared is odd, doesn't that mean A will also be odd? Well, I believe that would make sense, right? Because if A squared is odd, like let's say the answer is 121, and if I say what's A squared then to get that, wouldn't you say that it would be 11 squared? And 11's odd, and that's odd. So yeah, I would say the converse is still true for this one. Now, this is where the converse is not going to be true. I already know this because a parallelogram, the attributes to be a parallelogram is that it has to have 4 sides and it has to have 2 pairs of parallel sides, okay? So a parallelogram could look like this. That's got 2 pairs of parallel sides. It could look like this, if my, lines are straight. So let's reverse this. If ABCD is a parallelogram, here's a parallelogram. Whoa. If ABCD is a parallelogram, then it's a square. Well, that's not true because I just made a parallelogram and it's not a square. The attributes of a square are that it has to have 4 sides all the same length. There has to be 4 90-degree angles. There has to be 2 pairs of parallel sides. So yes, this converse is not true. And then it says if it is false, give a counterexample. So I want to make a new example that would work, okay? Or just give a reasoning why it doesn't work. So I could say for number 4, false, comma, a parallelogram does not have to have 4 sides the same length like a square does. That would be the counterexample. That'd be the reason why it doesn't work, okay? Okay, well, I'm glad we went over that because now we know what a converse is. Important things to know, I guess. Converse is just, can you reverse the statement to make sure it works both ways? Okay, moving on with our lives. Now we are doing number 5. Number 5 says, tell whether the triangle with the given side lengths is a right triangle. So I want to see if I could put a square corner in there. So we just have to prove it with the Pythagorean Theorem. 8 squared plus 15 squared equals 17 squared. All right, so let's find out. I've got 8 squared, which is 64. 15 squared. You think I would have this memorized by now after doing it for like a week straight? But alas, I'm still double checking it. 225. And 17 squared. 289. So is 225 plus 64 289? It sure is. 289 is equal to 289, so I would say number 5 is a right triangle. So my answer would be all of this plus the word yes. Right triangle. Sweet. Okay, number 6. Okay, let's find out if this is a right triangle. Let's do the legs squared. So 36 squared plus 27 squared. Does it equal 45 squared? Well, I'm going to get my calculator out. 36 squared is 1,296. 27 squared is 729. And 45 squared is 2,025. Okay, so 1,296 plus 729 is 2,025. Yay, so another one that I could say, yes, it is a right triangle. All right, number 7. All right, we got 8 squared plus 8.5 squared. Does that equal 11.5 squared? Well, 8 squared is 64. 8.5 squared is 72.25. 11.5 squared is 132.25. All right, let's see if it works. 64 plus 72.25 equals 136.25. Darn it. So close. So I would say this is a no. Not a right triangle. Close, 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 though. Remember, if I'm going too fast, please click pause and write these things down at your own pace. 8, 9, and 10, we are still trying to prove if it creates a right triangle. But this time they just gave us side lengths. How do I know who is going to be a squared, b squared, and c squared? Well, obviously, the big number is going to be c squared because the biggest is the hypotenuse, right? Does it matter who is a and who is b? No, not at all. So it doesn't really matter for these last ones. So I'm just going to say 14 squared plus 19 squared. Does it equal 23 squared? Well, let's find out. 14 squared is 196. 19 squared is 361. 23 squared is 529. 361 plus 196 is 557. This is a no. Not a right triangle. Ooh, fractions, your guys' absolute favorite. Okay, just by looking at this, who's the bigger number? Well, I've got 1.5 and I've got 1 1/5. How do I know who's bigger? Well, I like to think of Snicker bars, right? If I had 2 Snicker bars the same size, I cut this one in half and cut this one into fifths. Oops, I cut those fifths not very equally. If I said 1/5 versus a half, obviously that's the bigger one. 9/10 isn't even 1 whole yet, so he's tiny. We don't count him. Okay, so let's go ahead and set this up. I've got 9/10 squared plus, bless me. Whoa, that's a fun thing on the video. Okay, 9/10 squared. You know what I would do on my calculator? I would just put 9/10 in as a decimal, which is just 0.9. 0.9 squared is 81. Oh, sorry, 0.81. 1 1/5. 1/5 as a decimal is 0.2. So I could put 1 1/5 in my calculator as 1.2 and then square it. Oops, I put a plus sign right there. That should be an equal sign. And then I've got 1.5. So once again, put 1.5 as 1.5 and then square it. That is 2.25. All right. Is 0.81 plus 1.44 2.25? Yes, it is. So my answer here would be yes. This set of numbers creates a right triangle. All right, next one. All right, big guy is going to be my hypotenuse. So I've got 1.4 squared plus 4.8 squared, does it equal 5 squared? I can already tell this might not work because 5 squared is 25. And 1.4 squared, let me see here. That's 1.96 and 4.8. Well, you never know, guys. This actually might work. I forget that when you are square rooting decimals, things are pretty small still. Okay, so 23.04 plus 1.96, that should equal 25. It was deceiving. 25 equals 25, so this is a yes. It does create a right triangle. Okay, here comes the problems with distance formula. Fun, fun, here we go. Some of these we actually used in our notes as examples. Find the distance between the 2 points. If I don't have a coordinate plane, which I don't, I have to use the distance formula. I'm going to use the distance formula and say it a lot in here so that you guys can remember it. Distance equals the square root, nice big long square root, of the change in x's. Where's my x's? Right there and right there. 1 minus 7. Change or difference means subtract, right? And then square it. Now the change in y's. Where's my y's? Right there and right there. So I'd say 2 minus 6 and then square it. Okay, now we just do what's in the parentheses first. 1 minus 7 is negative 6. 2 minus 6 is negative 4. If things are in parentheses, that actually means like negative 6 times negative 6, which would be a positive number. So that's 36. Negative 4 times negative 4 is positive 16. 36 plus 16 is 52. Now don't forget, we got that square root up there. D equals the square root of 52. Now what we've learned is if the square root of 52 is nothing nice, which it's not going to be. I'll take the square root of it real quick. Square root of 52, 7.2111102550927979942. Yeah, see, nothing cute. If that's the case, and this does not equal a nice, cute number, it's not a perfect square, just leave it as this. It's totally fine with me, okay? I mean, I would love it if it would make a nice number, but it doesn't. Okay, here we go. Distance equals the square root, boop, change in x's squared, plus the change in y's squared. X's, let's subtract them. 4 minus negative 1. And then here's my y's. Let's subtract them. Negative 5 minus 7. Negative 4 minus, 4 minus negative 1. That's like a plus, so this would just be 5 squared. Negative 5 minus 7. Signs are the same, so we just add. That'd be negative 12. Okay? 5 squared is 25. Negative 12 squared, that's just 12 times 12, really, because 2 negatives make a positive, which is just 144. All right, 144 plus 25, 169. Oh, I know this is going to square root nicely. This is the one I said, oh, I can never remember this one. Remember? It's 13. Okay, so these 2 points are 13 units apart. I love it when it equals a nice number. Next one. The distance equals the square root. Change in x's. Oops, I'm actually going to put in the x's this time. 2 and 7 squared plus the change in y's. Okay, 7 minus 2, 765, that would be negative 5 squared. 4 minus 2 is 2 squared. 5 times 5 is 25. 2 times 2 is 4. That equals 29, the square root of 29. And I can't think of a single number that multiplied by itself is 29, so I'm guessing we're just going to leave 29 just as it is. 29 squared is 5.385164. Yeah, ugly, so we can leave it just like that. All right, on to the next set of problems. 14, 15, 16, same thing. Distance equals the square root. Change in x's, so I got -1 minus 1 squared, plus the change in y's, -3 minus 3 squared. -1 minus 1, signs are the same, just add, that's -2. -3 minus 3, signs are the same, just add, that's -6. 2 squared is 4, 6 squared is 36. Square root of 40. Nothing times itself is 40, which means I'm just going to leave it as distance equals 40. All right, the next one, I believe this is the one that's in our notes. Yep. So I'm going to skip 15. 16. Did I do 16 as well? I don't think so. Distance equals the square root. Change in x's squared plus the change in y's squared. That makes a double negative. 12 plus 12, that is 24 squared. 5 plus 2 is 7 squared. 24 squared, boop, boop, 24 squared is 576. 7 squared is 49. 576 plus 49 is 625. And guys, that is one that does equal something nice. I can remember this. 625, the square root of that is 25. Ba-boom. Done. Hopefully you guys are writing all of this down. It would really not be fun to have to rewatch the whole video just to write all the stuff down. Okay. Let's just do the error analysis and then be done. Describe and correct the error in finding the distance between these 2 points, right here and right here. Okay, so there's a point, there's a point. Let's just take a look at what happened here. I'm going to actually get rid of my highlight, and I'm going to use my highlight to help me figure out where they put things. X's are going to be yellow, and let's have y's be blue. So they said distance equals the square root of. Okay, so they started with a 7 minus -3. So far, we're doing okay, honestly. And then they said minus the 4 minus the -2. You know, I was thinking that the error was going to be that they were goofy and put, like, these numbers out of order somewhere, like somewhere crazy. That's why I decided, oh, let's highlight. But while reading this, I found the error right away, and I hope you guys did too. The error was not the order in which they put the numbers. They actually did a pretty good job of putting their numbers in the correct order. Like if they started with that 7, then that means they needed to start with this 4 next, right? So, I mean, they did a good job there. But remember, the formula is distance equals the square root of change in x's squared plus the change in y's squared. Okay, so there's the error right there. That sucker right there is a problem. So can we correct it now? Okay, so they're saying that 7 minus -3, that's 7, 8, 9, 10. 10 squared is 100. They did that great. And then they said 4 minus -2, that's just 4, 5, 6. 6 times 6 is 36. They did that great. It's just this little sucker right there. 100 plus 36. That gets me the square root of 136. And the square root of 136 is, oh man, I thought it was going to be something nice. It's nothing nice. So we can just leave it at that. Distance equals the square root of 136. Don't forget, we're adding, we're not subtracting in the center. All right, guys, that was a lot of work. So I'm really, really proud of you for sticking through this video, watching it to the end. I'm really proud that you guys are working so hard on your homework, and I think that if you're still listening, you can do a bonus question for extra credit because you're listening. And that would be awesome. So here's your bonus question. Number 18. A post and a beam frame for a shed is shown in the diagram. Does the brace form a right triangle with the post and the beam? Explain. All you have to do is look at that and figure out if this is a right triangle by taking a squared plus b squared and see if it equals c squared. Okay, I want you guys to do that one on your own, and that'll be the question that if you get right, you get that extra bonus point, okay? All right, good luck. Don't forget to put your name on this and turn it in when you're done. All right, see you guys on Monday.